Alright, so today we're going over Newton's method. So Newton's method is essentially a way to approximate a zero or a root of a function. So given all, of course, x of n, which is an approximation of the root, and you would find xn plus 1, which would be a closer approximation of the root or and a zero of the function. So this is a essential equation you need to memorize. It's going to be xn plus 1 is equal to xn minus f of xn over f prime of xn. And uh, most times you're going to be given the function f of x, you would derive it to find f prime. And then most times you would be given xn, which is approximation. And then you would plug it all in here to find xn plus 1, which would be the next approximation of 0. And let's say that we have x cubed plus 4, and we need to find the zeros of this. You can't actually factor this out to find the zeros. And let's say the question gives us an xn value of 1. What we would do is plug in this xn and then the f of x and the f prime of x into here, and we would get x2 or xn plus 1, which would be a closer number to the 0 than 1. Because of course 1 is not a 0 of the function. Alright, so let's take a look at number 1. So number 1 is the figure shows a graph of a function f. Suppose that Newton's method is used to approximate the solution of the equation f of x equals 0. With the initial approximation of x1, we need to find x2 and x3. So let's write down Newton's method up here. It's going to be xn plus 1 is equal to xn minus f of x over f prime of x. And now we know the xn is going to be x1. So let's say x2 is equal to x1, which is going to be 6. And that's going to be minus f of x. So our x value here we're going to go off of is at x equals 6. So which is going to be 1, 2, 3, 4, 5, 6. So first we're going to have to put f of x, which is going to be the y value at x equals 6, which is going to be around 0.8. Negative 0.8 rather. And then the derivative, which is going to be the slope at x equals 6, which is going to be, I'd say that is around half. And now we could kind of simplify this. So if we simplify, we'll have positive 0.4 because a negative and negative is positive, and 0.8 divided by 2 is going to be 0.4. And so our x2 is going to be 6 plus 0.4. We add that, we're going to have an x2 of 6.4. And we could kind of see that our original approximation was at x equals 6. There isn't a 0 at x equals 6. And now our second approximation is at 6.4. And 6.4 is a lot closer to the 0 because we can approximate the 0 to be at around 6.8, I'd say. And then this 0 over here would be probably at I'd say 2.8. And now we need to find x3. So we have x2, that's going to be our first part of the answer. And now x3 is going to be equal to x2, which is 6.4. And that's going to be minus f of x over f prime of x. So the y value at 6.4 is going to be around, we could say 0.5. It would be half, and then the slope at 6.4 would be we could say about 3/4, or we could actually say it's 1. So, oh yeah, it would be negative 0.5 for the y value over the slope of 1. So if we simplify that, we're going to have 0.5 over 1 is going to be 0.5, and then negative negative is going to be positive. So we have 6.4 is plus 0.5. Oh no, x3. So we're going to have x3 is equal to 6.9. And we could see that 6.9 is dangerously close to 0, like the actual 0. So x3 is as we go up in the x2 to x3, we're getting closer to the actual zero of the graph, as you can see right there. But those are going to be your x2 and x3 for the answer for A. And now B is would x1 equals 8 be a better first approximation? What we could do first is just find x2 using x1 equals 8 and see if it's closer to 6.8 than 6.4. So what we could do is we have the Newton's method up there. We're going to have x2 is equal to x1, which is going to be 8, minus f of x. So the y value at x equals 8 is going to be right here. That's 8. The y value is going to be it's going to be 3 over the slope, which is going to be, I'd say that's 3. The slope is going to be 3, and that means that x2 is going to be 8 minus 1, so x2 is going to be equal to 7. So we could see that if we're given a first approximation of x1 equals 8, we get an x2 value of 7, which is actually a lot closer than 6.4 is to the actual 0. So for B, it would just be yes. And then your explanation would just be the math here. But you could also show that 7 is way closer to 6.8 or 6.9 than 6.4 is. So number 5 is which of the initial approximations x1, a, b, c, or d do you think Newton's method will work and lead to the solution of the equation f of x equals 0? So our plan is to get an approximation at x equals 0 because that is the only 0 of the function. So essentially what we could do is find out which point is the closest to that 0 and closest in terms of the slope and the y value. But we could also plug it in. So let's just give all these values. Let's say b is 1, c is 2, and d is 4. And let's say a is negative 2. So let's real quick figure out b. So let's do x2. Let's say x1 is b, and b is also going to be equal to 1. So let's say x2 is equal to 1 minus f of x, which is going to be the y value at b, which we could say this is 1, and this is going to be 2, and this is going to be 3. So at 1, it's going to be, so we have f of x of 1, and then the slope is going to be approximately 1, I'd say that. And we're going to get x2 is equal to 1 minus 1, which is 0. So x2 is equal to 0. And you could see 0, the approximation of 0 is exactly where the 0 of the function is. But of course, this is not always going to happen. We just got lucky. But you can kind of visualize with the math here how picking B is the best choice in which the Newton's method would work the best. You could even plug in C. We could actually do that right now. So let's say x1 is equal to, should we plug in C or, yeah, let's plug in C, because D we already know that's not going to be a good answer. Let's say we plug in C, and C is equal to 2. So x2 is equal to 2 minus f of x over f prime of x. So f of x at C is going to be 2, and then f prime of x at C is going to be approximately 1/2. Yeah, let's say 1/2. So that's going to be 0.5. And then if we simplify it, it's going to be x2 is equal to 2 minus 4. And that's going to be x2 is equal to negative 2. And negative 2 is substantially farther from the 0 than the approximation we made earlier. So we can clearly see that B is the best initial approximation for us to make to lead us to a solution of f of x equals 0. Alright, so let's take a look at number 6 and number 8. So number 6 and number 8, we have to find x3, and we're given x1 for both of these, and now all we need to do is plug in Newton's method, which is going to be xn plus 1 is equal to xn minus f of x over f prime of x. So now we're actually given an equation and not a graph. So we could find the answers a lot, without eyeballing stuff. So let's first find out x2 of number 6. Number 6, we have 2x cubed minus 3x squared plus 2 equals 0. And then our first approximation is at -1. So x2 is going to be equal to x1, which is going to be -1, minus f of x over f prime of x. So what we need to do is plug in -1 into this equation. So if we plug in -1, we're going to have 2 -1 squared minus 3 -1 squared. Oh, this is a cube. And then plus 2. So here we have -2, and then here we would have -3 plus 2. And that would give us an answer of -3. So we would have -3 on the top, and then on the bottom we would plug in this -1 into the derivative of this function, because f prime of x. So derivative of number 6 is going to be 6x squared minus 6x, and then the 2 would go away. And now all we need to do is plug in -1, so we have 6 -1 squared minus 6 -1, and if we plug it in, we have -1 squared, which is 1, 6 minus uh, -6 times -1, it's going to be positive. So we actually have 6 plus 6 is equal to 12, which means that down here we're going to have 12. If we simplify that, we're going to have x2 is equal to -1, and these two negatives cancel out, so it's a positive, plus, and that's going to be 1 over 4. So we have x2 is equal to -3 over 4. And now using x2, we have to find x3. So let's find that. So x3 is going to be equal to x2, which is -3 over 4. And that's going to be minus f of x over f prime of x. So what we do is take the derivative and the original function and just plug in -3 over 4. So let's plug in -3 over 4 for number 6. So we could take out some of these stuff going on here. So we do that. Now we're going to have, let's see, 2 is going to be 2 times -3 over 4 to the third power minus 3 -3 over 4 squared, and then plus 2. So -3 over 4 to the third power is going to be -27 over 64, and then minus 3 times 9 over 16, and then that's going to be plus 2. And what we could do now is multiply it out. So we're going to have -54 minus 64 minus -27, or minus 27 over 16, and then plus 2. And now we need to have them have common denominators. So we're going to multiply this fraction over here by 4, and then this, we're going to put it over 64. So we're going to multiply by 64. So we're going to have -54 over 64 minus 27 times 4, which is going to be 108 over 64, and then plus 128 over 64. And if we just add that all together, we're going to have -34 over 64 as our final answer, but we could also, or not our final answer, our final f of x value, but we could simplify that to -17 over 32. So on the top here, we would have -17 over 32. And let's also make some more space so we could find the derivative, or rather plug in the derivative. So for the derivative, we have 6x squared minus 6. Now we plug in -3 over 4 into it. So we're going to have 6 times -3 over 4 squared minus 6 times -3 over 4. So if we multiply that, we're going to have negative 3 over 4 squared is going to be, we have 6 over here, negative 3 over 4 squared is going to be 9 over 16. And then minus, we can multiply out 6 right now, so it'll be plus, because negative, negative, that would be plus 18 over 4, yeah. And we could also multiply this out, so we're going to have 54 over 16 plus 18 over 4. And we want to turn this 18 over 4 into a common denominator of 54 over 16. So we're going to multiply this by 4. So 18 times 4 is going to be 72 over 16. So we have 54 over 16 plus 72 over 16. And that would be 126 over 16. But we could also simplify that to 63 over 8. And so we'll have 63 over 8 on the bottom. And let's make a little more space so we can now find out x3 in its whole. So let's take that out. So now we have negative 3 over 4, and we have x3 over here equals negative 3 over 4 minus, and this is going to be negative 17 over 32 divided by 63 over 8. We could write it like this is a lot better. And now what we could do to find this out is just cross multiply. So we're going to end up having negative 3 over 4, and that's going to be minus, if we cross multiply, it's going to be 17 times 8, which is 136 on the top. And then on the bottom, we're going to have, and we could also keep this negative here. We're going to have on the bottom 32 times 63. So it'll be 2016. And now we could also simplify that. That would be 68 over 1008. And if we simplify that one more time, we could do that real quick. So that would be, we would have, I believe, 34 over 504. And yeah, we could simplify it one more time, divide by 2. It's going to be 252, 17 over 252. And that would be our, the cumulative of f of x over f prime of x. So now we have negative 3 over 4 all, down here. And we have that minus, that's actually minus and minus, so it's positive 17 over 252. And now all we need to do is add these together. So we could turn 3 over 4 into a fraction over 252. So all we need to do is multiply top by 63. So we multiply top by 63, we have 189. And let's create a little more space for us to use here. Let's use all this space. So we're going to be left with negative 189 over 252 plus 17 over 252. And now we could add them together since they're common denominators. So we're going to have negative 172 over 252 as our final answer. But you could also simplify that to 86 over 126. And if you divide by 2, actually, again, that would be 43 over 63. And I don't think you could divide this any further, so your x3 value would be negative 43 over 63, which you can approximate to be about, 0.66869, around there. So that is going to be our x3 value for number 6. All right, so let's take a look at number 8. So number 8, we have x to the 5th power plus, let me write down Newton's method first. So we have xn minus f of x over f prime of x. It doesn't fit there. But if x to the fifth power is equal to x squared plus 1, so we could move everything to one side, but we really don't have to. But so we have to find x2 first before we find x3. So x2 is going to be equal to x1, which is 1, as we're given, minus f of x over f prime of x. So what we need to do is plug in 1 into this equation. So we're going to have 1 to the fifth power is equal to 1 to second power plus 1. And we're going to be left with 1 is equal to 2. And if we subtract 1 on both sides, we're going to have an answer of 1. So we have 1 on the top for f of x, and then f prime of x is going to be a derivative of number 8, so that's going to be 5x4 is equal to 2x. And now all we need to do is plug in 1 into this derivative function. So we plug in 1, we're going to have 5, 1 to the fourth power is equal to 2, 1. And 1 to the fourth power is going to be 1, so it's going to be 5 is equal to 2. Subtract 2 on both sides, we're going to have an answer of 3. So we have 3. So our x2 value is going to be 1 over, or 1 minus 1 over 3. So x2 is going to be equal to not 2 over 3. And now using this x2, we have to find out x3. So let's make a little bit of space here and a little bit of space down here and this right here. And I did delete I deleted the derivative, which is not ideal. But we could just write it out again. It was 5x4 is equal to 2x. And now to find the x3, we need to apply the same rules. So x3 is going to be x2, which is 2 over 3, minus f of x, which is going to be 2 over 3 plugged into this, or the original function, I mean. So we have 2 over 3 to the fifth power is equal to 2 over 3 to second power. We can actually write that out. It's going to be 4 over 9 plus 1. And 2 over 3 to the fifth power is going to be, we're going to have 32 over 729. And that's going to be equal to 4 over 9 plus 1. And we could rewrite this out as fractions of 729. So we have 32 over 729 is equal to, this would be 9 times, we would multiply the numerator by 81. So we would have 4 times 81, which is going to be 324. And then plus 1, which is just going to be 729 over 729. Now we can do the subtraction out and the addition. So we have 729 plus 324 on the right side. And then we bring 32 from the other side. So we're going to have 1054 and then 32. So if we bring it to the other side, we're going to subtract it. So it's going to be a 1053 actually. If you bring it to the other side, it's going to be 1053 minus 32, which is going to be 1021 over 729. And that is going to be our f of x values, or f of x value rather. So it's going to be 1021 over 729. And then for this, we have to, now to find f prime of x, we have to plug in 2 over 3 into the derivative. So let's create some more space down here again, like that. And now we're going to plug it into a derivative. So we're going to have 5, 2 over 3 to the fourth power is equal to 2, 2 over 3. And 2 over 3 to the fourth power is going to be around 16 over 81. And then we have 5 over here. And now we're going to have equal to 4 over 3. And so we can multiply the left side out. We're going to have 80 over 81 is equal to 4 over 3. And now we need to turn them into common denominators. So we need to multiply the right side by 27. So we're going to have 80 over 81 is equal to 27 times 4, which is 104 over 81. Now we multiply 80 over 81 over on both sides. So we're going to have 104 minus 80 over 81. So we're going to have 24 over 81 on the denominator here. And now we're going to be just simplifying all this and doing some calculations. So we have 2/3 minus, or actually we can just, we can do what we did before. We can write 1021 over 729. You can also simplify this before you multiply it out. And that's going to be divided by 24 over 81. And now we can just cross multiply. So we're going to be left with 2 over 3 minus, and we're going to have 1021 over, or times 81, which is going to be 82,701 over 729 times 24, which is going to be 17,496, right? Yeah. And this is a equation here you could simplify out, which I don't recommend it doing that by hand. But so we're going to multiply this 2 over 3 by 5,832 so that we can get a common denominator. So we're going to have 11,664 over 17,496 minus 82,701 over 17,496. And if we do that, we're going to get negative 71,037 over 17,496. And this seems a lot very far-fetched from the x2, but this value, when you actually simplify it down, it's going to be around like -4. But most times they won't make you simplify this down. I also don't uh, believe that doing it by hand is a very good idea. But this would be our x3 for number 8. Alright, so I want you guys to try number 4. So number 4, you're going to be using the initial approximation to find out what the x2 values are going to be and how much closer it is to going to be to 0. So our zeros are going to be at 2 and 6. So ideally you want your x2 values to be closer to 2 or 6 than the original approximation. So you could pause the video and try that out. Alright, so let's take a look at A. So A is x, first approximation of x is going to be 0. So we could write down, we could use Newton's method. So x2 is going to be x1, which is going to be 0, minus f of x, which is going to be at 0. F of x, since we don't have any values here, let's just say that's 1. So we have 1 over f prime of x, which is going to be a derivative, which is approximately, I'd say, 1. So our x2 value here is going to be -1. And we could see from 0 to -1, we're actually moving away from a 0. Because these are zeros of the function, it's moving closer to a horizontal asymptote. Because the graph also has a horizontal asymptote at negative and infinity and it oscillates towards 0. Let's check out b. So for b, we have x1 is equal to 1. So in order to find x2, we're going to have x2 is equal to 1 minus f of x, which is going to be at 1. It's going to be around, I'd say that's 2. So we have 2, and then the derivative is going to be 0 because it's a flat line, it's a horizontal tangent line. So this is does not exist actually. Because 2 over 0 does not exist, which means that, 1 minus does not exist would not give us an answer that exists. And then we're actually going to skip C and D. We're going to go straight to E. So E is going to be x1 equals 5. So x2 is equal to 5 minus f of x, which is going to be down at x equals 5. It's going to be around, we could say as -1. So let's put -1 at the top, and the slope would be around, I'd say that's 1. So we would have 5 plus, because it's 2 negative, 5 plus 1. So x2 would be 5 plus 1, which would be 6. So our x2 for E would be a 0. So the x1 approximation of 5 is actually correct. I mean, correct or not correct, but rather accurate, because it gives us an x2 approximation at a 0 exactly. However, B, x1 equals 1 does not give us an answer that exists. And A, the approximation of 0 actually takes us away from a 0. It gives us -1. Alright, so that was basically for Newton's method. So this is the equation to remember for Newton's method, or rather the formula. And most times Newton's method is going to be questioned upon some graphs. So you'll need to know how to eyeball xn, f of x, and then f prime of x. Sometimes you'll be given equations and told to find x2 or x3. In that case, you would find derivative and then plug in the respective values. So yeah, it's basically it.